Hello everyone, myself Sravanthi, working as an assistant professor in Department of Data Science and Cybersecurity in MLR Institute of Technology. Today our topic is Recursive DSM Parser. So today we are going to cover what is Recursive DSM Parser, what are the steps that are used to construct Recursive DSM Parser, and with an example. So the Recursive DSM Parser comes under top-down parsing. Okay, there are two types of parsings are there, top-down and bottom-up parsing. This Recursive DSM Parser comes under top-down parser. What it does is it processes the input based on set of recursive functions where each processor or where each function corresponds to a grammar. Nothing but here we are going to have a grammar. Grammar consists of the productions, and for each grammar we are going to write some set of functions. We are going to write some set of function. Each function that is corresponding to the grammar rule. It parses the input from left to right, constructing a parse tree by matching the grammar's production rules. We are going to scan here in top-down parsing, we are going to scan from left to right. So, nothing but we are going to scan it from left to right, and based on that, we are going to construct the recursive DSM parser. Here, to construct the recursive DSM parser, first the given grammar, we need to check whether the grammar is free from left recursion and left refactoring. If it is free from these two, then only we can construct the recursive DSM parser. If suppose the given grammar is having left recursion and left factoring, we need to avoid left recursion and left factoring, and then only we can construct we are going to modify the given grammar, and then only we are going to construct the recursive DSM parser. So what are the rules that are used to construct the recursive DSM parser? For example, if the input is non-terminal, if we find the non-terminal as an input, then we are going to write the procedure. We are going to write the procedures are nothing but we are going to write the functions. Here in recursive DSM parser, we are going to call it as a procedure. So, rule 2. If input is terminal, suppose if the given input is terminal, then what we are going to do is we are going to compare the input with the symbol. Suppose I am having plus or multiplication, some terminals are there. These terminals, these input is checked whether that is equal. If it is equal, then we are going to increment. If it is not equal, then we are going to for the next procedure. See, if input is terminal, compare terminal with the input symbol. If both are equal, then increment input pointer. Then we are going to increment the input pointer. If any non-terminal having multiple productions, write all the productions in single procedure. For example, I am having E tends to FT. Nothing but here I am having it is a non-terminal, and here also I am having a non-terminal. So these two non-terminals are going to be written in a single procedure. Procedure is nothing but function. In the single function, we are going to write multiple non-terminal productions. Nothing but in a single production, if I have more than one non-terminal, all these non-terminal procedures are written in a single procedure. Nothing but we are going to call all those non-terminal functions in a single procedure. If any non-terminal having multiple productions, write all productions in a single procedure. So for F function, I will be going to write here, the T function is also going to be written in a single procedure. If it does not have any main function and declarations. Here we don't have the main function and as well as declarations. What are the steps that are used to implement recursive DSM parser? Match tokens from the input string. First, we are going to construct the recursive DSM parser. Then after, we are going to check one input string we are going to take. We are going to check whether the input string is matching or not. If it is passed successfully, then we are going to tell that the given string is correct. Match tokens from the input string. If the parser read tokens from an input string, use functions to represent non-terminals. So, just now we discussed functions are used to represent non-terminals. Functions are nothing but the procedures that are used to represent non-terminal. Each non-terminal in the grammar has a corresponding functions. Yes. In the grammar, we are having, so a grammar is nothing but we are going to have some productions. E tends to ET, T tends to star F, F tends to ID. Some production, for example. Each production is going to have one procedure. See here, each non-terminal in the grammar has a corresponding function. Each non-terminal has one function. Recursive calls. These functions calls each other recursively to process the input. The name itself tells us that it is a recursive call parser. Okay, so nothing but here we are going to use recursive calls. Check for errors. If the input does not match the grammar, if the input, I'm going to give some ID plus ID. If according to my parser, according to my grammar, if that string is not matched, then it reports an error. Nothing but we are going to check some errors are there. This string is not matching to the given grammar. So it is not a recursive descent parser. So these are the steps that are used to construct a parser. So let us take one example and first we construct the recursive descent parser. To construct the recursive descent parser, first we need to check whether the grammar is free from left recursion and left factoring. So this is my grammar. A grammar consists of productions. See here, this grammar is having the left recursions. See here, A tends to A alpha. Nothing but it is having a left recursion. We are going to overcome these left recursion. After removing the left recursion, I am going to get the grammar is this one. I'm going to eliminate. This is my original grammar. This is modified grammar. Here I am having in the given grammar, I am having the left recursion. I am going to eliminate the left recursion. So this grammar, it is in the form of A tends to A produces A alpha. It is in the E and E. Both are matching. T is matching. F is not matching. So these only the last production is not a left recursion. The top two are having left recursions. So we are going to remove that left recursions. After removing the left recursion, we are going to get the updated grammar is this one. Now for this grammar, we are going to construct the recursive descent parser. Nothing but algorithm we are going to construct. So what we have discussed how to construct a algorithm is nothing but if I have a non-terminal, if I find non-terminal, we are going to write the procedures. If we find a terminal, we are going to check the condition by using if condition. If input is equal to terminal, if it is matching, then we are going to increment it. If it is not matching, we are going to come out from that if condition. In a grammar, in a single production, if we have more than one non-terminals, we are going to write those multiple non-terminals in a single procedure. These are the rules that are used to construct the algorithm. So first see here. E tends to, let me take E produces T E dash. This is my first grammar, first production. For this production, I am going to write an algorithm. So as E is what? It is a non-terminal. So we are going to represent it with using a procedure E. So it is a function, we are representing it with open and close bracket, procedure, open and close. So in this production, what are the things I have? Here T is a non-terminal and E dash is also a non-terminal. So these two are nothing but it is a functions. So in a grammar, in a production, we can have multiple non-terminals. All the non-terminals are written in a single procedure. See, I have find one non-terminal T and the other one. I have written those two in a single production. Why? Because it is pointing to single production. Okay. E and it is a non-terminal. So we are going to call it as a function. E dash, it is also a non-terminal. So we are going to write it as a function. So semicolon. Next one is E dash produces plus TE dash. E dash produces plus TE dash or epsilon. See here, it is E dash is nothing but it is a non-terminal. So we are going to write here procedure. So the question you may get is here, it is also a non-terminal. Why we are not writing a procedure? See, each production, the LHS part is going to have the procedure. All the non-terminals are going to have the procedure. These terminals, it is pointing these TE dash are nothing but the functions of that procedure. E dash, it is also a procedure of E dash plus it is a terminal. So we are going to check the condition. If input symbol is equal to plus, then what we are going to do, then advance we can write, or I can write it as input plus plus. Then we can also write input plus plus. Nothing but we are going to increment this input. If I find here plus, nothing but if suppose I am giving the input string as plus, then plus and plus. If both are matching, then I can tell it as input plus plus or advance. Anything. So the next character I am having is T. It is a non-terminal. So we are going to call that function T. Next E dash. It is also a non-terminal. So I am going to call the function. So this is about the E dash procedure. So the next I have is E. E is there. It is nothing but what? Epsilon. So just simply I can write here it as written. Epsilon is nothing but it is not returning anything. Nothing is there over there. So we are just going to write it as written. So the next one, procedure of T. So the T function is T produces F of T, F T dash. So T is nothing but it's a non-terminal. So procedure T, and F is a function. So F function and T dash function. This is of single procedure. It's completed. Next, T dash produces star F T dash. T dash is nothing but it is a procedure. Each production is going to have single procedure. And if that production is having multiple non-terminals, we are going to write all those in a single procedure. Here I have plus. So plus is nothing but it is a non-terminal. So we are going to check the condition. If input symbol is equal to star, then advance, or we can also write it as input plus plus. We are going to increment the string. Next, what I have F. It is a non-terminal, and T dash. It is also a non-terminal. So we are going to call the functions. The next one. F produces ID. F produces ID. So procedure of F. If input symbol is equal to ID, then advance. Okay. Else. What I am going to write? Actually, this is nothing but what I have here. The grammar is E open close bracket E ID. Open close bracket E ID. So this is single statement. So first I have written ID. Input symbol is equal to ID, then advance. Else, if the given input string is not matching to this ID, then what we are going to do? Else, if input symbol is equal to, what I am having, open bracket. So it open, closed, or by anything. Nothing but these all are terminals, open bracket, then advance. Next, what I have, E is there. E is a non-terminal. So we are going to call that function. Next I have is closed bracket. If input symbol is equal to closed bracket, then advance. So nothing but if this condition is not true, then it is going to generate the error. Then this condition is not true, it is going to generate the error. So this is about the construction of the parsing table. For example, if I have a string ID plus ID. So this is the algorithm we have constructed. For this algorithm, if the given input string, we need to check whether this input string is matching or not. So how we are going to check? So it comes here, ID is there. So procedure, the grammar starts from here. Okay. So ID, it is written in the form of array format, ID plus ID. It comes here, T function. So what it is a function call. It checks the definition, nothing but where the procedure of this T is there. So the T procedure is here. Then again internally I have F. F is also a function call. So we are going to check the procedure of this one. I am finding here the procedure. So what I have taken my input string, input is ID plus ID. If input symbol is equal to ID, yes, input symbol is equal to ID, then what I am going to do? This is matching. So what it is going to do? Advance. So the nothing but this is matched. My input string is matched. Now my cursor is moving to the next symbol, plus. The next symbol, it is more. Plus. Again it checks. Input ID is equal to plus. No. It is false. Here I am having plus and here I am having ID. So it returns back over here. So the next one what I have here, T dash function. Nothing but it checks the definition of this one. So it comes here. Input symbol is equal to star. But here I am having plus. Plus sign star are not matching. So it is nothing but it comes out of the loop. So what I am having here, F function. Again it comes. It is not matching. It comes here. Open bracket. It is also not matching because plus is equal to the open bracket. It is not matching. It comes here. It is closed bracket and it is plus. It is not matching. So then again it comes here, T dash is nothing but the same function. So it is not matching. Here I have plus and here I have plus star and here I have plus. It is not matching. It comes out of this procedure T dash. From where I have called this T dash, I call from here the T dash. So this function is also completed. From where this T dash is called? From this function. This function is completed. Then comes to the E dash. E dash is nothing but it comes here. If input symbol is equal to plus, yes, input symbol is equal to plus. It is matched. So then it is nothing but advanced. Nothing but it is incrementing. From here, it is incremented to here. From here, it is incremented to here. Now again what I have, T dash. So nothing but function call is there. So we are just going for the T function. Again I have F. It comes here. F function. It checks ID. ID is equal to ID. It is matching. So advance. Nothing but it comes here. it is the end of the string. So there is no more strings are there, nothing but as the input string, it indicates the last symbol is dollar. It tells us that my string is completed. So the given string is matching my recursive DSM parser. So this is about the construction of the recursive DSM parser. Thank you.